Hi, welcome back to another TRS-80 math video. What I have today is a quadratic equation. Quadratic equations are in the form of ax squared plus bx plus c equals 0. That is the correct form. And here's an example with A as 2, B as 6, and C as 4. So now I've substituted A, B, and C, and we want to know what the x is. Okay, and what this is you'll get two answers. You'll get x1 down here and x2 as your answers. And there's always 2. And so we have no idea what x equals. We know what a, b, and c equals. So what we have to do is first factor the quadratic. There's 2 ways to factor a quadratic. If a is more than 1, as it is in this case, you group them. And so that's done by multiplying a and c. And if we multiply a and c, we get 8. Now, hopefully you can see my pointer. And then what you do is you factor all the factors of 8 that are in 2 parts. So the only factors of 8 are 1 and 8 and 2 and 4. And you want to pick the factors that, when added, give you b. So in this case, 4 plus 2 equals 6. That's the one we want to use because b equals 6. Once you have that information, you take b and you split it into 2 parts, a 4x and a 2x, which we got over here. And then you group them into 2 groups. Now you don't change anything, you just divide b into 2 separate portions. And you keep everything else lined up, don't change anything around, and you get 2x squared plus 4x plus 2x squared plus 4 equals 0. Okay, so now we have our, we're getting down, factoring this down. Okay, and then what you do is you factor out the greatest common factor for each group. So on the left hand side, we would factor out a 2x, and we would be left with x plus 2 in parentheses. And for our right side here, we would factor out a 2, and we would be left with x plus 2 in parentheses. Now you know this is done correctly when the parentheses match. So in this case, it's x plus 2. That is one factor of 2x squared plus 6x plus 4. We have to factor this first before we can solve the equation. So our first factor is x plus 2, and then what we do here is we take the 2x and the positive 2, we put those in parentheses, and that becomes our second factor, and it's a multiplication here. So if you multiplied this out using FOIL, you would end up with the original problem. I'm not going to do that here, but that's a way of checking your work. So our final solution is these 2 factors. Alright, so the next step is to solve the equation. Now, equation means setting your quadratic equal to 0, and that's what I've done all the way down the line. But what happens here is once you get to this point, they break off into pairs, and we have x plus 8 equals 0, and if we solve that, we get x2 is negative 8, so that's one answer. And then over here we solve 2x plus 2 equals 0. We move the 2 over, becomes negative 2, and then we divide by 2, and we get our second x, x1, our first x, and our second x. Doesn't matter which way, but so if we divide by 2, we get x equals negative 1. So that's our second answer, or our first. It's our first. Here's our first x, negative 1. Second x, negative 8. Those are the answers. Now, what happens is, if you plugged either one of these answers back into the original problem, it would become 0 equals 0, and you would have a perfect equation there. And that's, you know, I'm not going to check it, not on this video, but those are the answers. And over here, now, if you can see that this is a lot of work to get through. This is the quadratic formula in red, and it's found in the back of the TRS-80 manual. And so you can use it on your color computer to solve this equation and get these answers. Now, this quadratic formula you can use on a piece of paper and do it out, and you'll save yourself a lot of time. You won't have to factor and solve. What will happen is you'll do this twice and you'll end up with the same answers. If you see here, x1 would be the positive and x2 would be the negative. Now that doesn't have anything to do with the answers. What this means is that this is in two parts. The x is here, so x1 would equal negative b plus the square root of b squared minus 4ac, all divided by 2a. And if you plugged in the a, the b, and the c and did the math out, it would be much faster, and you would get the x1, and x2 would be the opposite of b minus the same routine here, and you would end up with x2. So the plus and the minus denote two separate calculations, and we can do this even faster by writing a color computer program or a TRS-80 program that would do this work for us, and in turn we could get our answers in seconds. So here is the super long way. Here is our next best bet, but our best bet would be using a computer and getting quicker answers, and that is what you're going to see next, so stay tuned. Okay, so welcome back, and here is the next part of this video. Okay, so now you're going to see the color computer in action here and what it can do. I'm going to list the program so you can see the different parts of it. So what happens is, now I did this yesterday, so I have to look back in here and see what's going on. All right, so so what happens here is, you know what I'm gonna do? I'm gonna run the program first instead of picking it apart right now. So I'm gonna use the same example that I showed you before. So what I have here is this would represent A, this would represent B, and this 0 would represent C. Now I did this really quickly because I wanted to get it done quick, so it needs some tweaking. But imagine that this is A, this is B, and this 0 is C. So we have A times x squared plus B times x plus C equals 0. And it's asking what is A. So in our case, A was 2. So now it rewrites the quadratic equation with a 2. So now we have 2x squared plus 0, we'll say bx plus c equals 0. Now it wants to know what b is. So in our case, b was 6. So it rewrites it again. 2 times x squared plus 6 times x plus c equals 0. And in our case, c was 4. So once we fill in the c, we have 2 times x squared plus 6x plus 4 equals 0. And if you go back to the whiteboard, you'll see that it's the same as our the example that I gave you. And as soon as we put in our C answer, what we want for C, it gives us our two answers, x1 and x2. And if you look back to the answers that I gave you on the whiteboard, x1 was equal to -1, and x2 was equal to -8. So that is, I must have done something wrong here. Yes, and I did. That's not an 8, that's a 2. That should be a 2. I don't know why I have an 8 there. It should be x plus 2. So x2 would equal, -2. Now this is exactly why you want to have some way of checking your work, which I didn't check my work, but the computer checked my work for me. So if you referred to the whiteboard, I actually had one answer wrong, and that's the whole reason why this is handy, because it checked my work for me and I didn't realize I messed up. Writing on a whiteboard is kind of messy when it's really small writing, and it's hard. I just misinterpreted the 2 for an 8. So x2 is equal to -2 and x1 is equal to -1. Now there are some problems with this. For some reason, this computer, you can't do two things with it. When you're using, if you're going to use the quadratic equation on this computer to solve problems, it's not exact. It doesn't, for some reason, there's 3 things that you can't do. And I'm trying to find fixes for this problem. The first problem is that if if you can't take the square root of a negative number, so if the portion of your problem where we have the square root, if that portion is negative, you'll have an FC error because this computer doesn't recognize negative square roots. And I went through that before in a previous video. So you have to make sure that you're not taking the square root of a negative number. That is a pretty big limitation because a lot of these problems will be negative square roots. And a negative square root is always an imaginary number. So I'm going to try to make a fix for that. I'm sure there's a way. The second problem is that what this computer does is that, and I'm going to list the program line by line here so you can see that how the program works. What it actually does is, now it will, the part that's under the square root, b squared minus 4 times a times c, that part of it has to be broken down. So you define z first as the part of the part of the quadratic formula that's under the square root. So you define that part as z, and again it would be b squared minus 4 times a times c. And then what you do is when you want x1 to print, you will use the positive here, and x2 will be the negative here. This is the entire thing right here. That's it, just this little part. But it has to be broken down into 3 steps. First, you have to identify what's under the square root as z, and then you have to break this down into plus and minus like I explained before. So x1 would be plus, x2 would be minus, and so in this case it would be the opposite of b plus the square root of z divided by 2a, or the opposite of b minus the square root of z divided by 2a, and you have to make sure that you have 2 parentheses on this side because square root has its own set of parentheses, and then it's encapsulated at each end divided by encapsulated 2a, and I get my answers. However, like I mentioned before, z cannot be negative. So once the work is done here, it cannot be negative because you can't take a negative square root on this computer. The second thing is that z cannot be 0. For some reason, this computer won't. Yeah, let's try that right now. Print the square root of 0. And it gives 0, but for some reason in the book it says that z can't equal 0. I don't know why. I'm just taking their word for it. So z cannot equal 0 and z cannot be negative. And the third thing is that in certain problems, and it's not just this one, if you, I'm going to list this one more time, 1 to 10. Now, if I use 5, 8, and 3, 5, 8, and 3, I get 2 answers. And these are the correct answers, but it's not gonna give you a fraction here. 0.6 is actually 0.6 is a division, is a fraction. I can't remember what it is, but it'll give you the decimal form of the fraction, so this is correct. But in certain cases, like the case of our last example, 2, 6, and 4, instead of and this has happened to me a couple times and I don't know why, maybe somebody knows why, I don't. It loses, like, some of the answer gets lost. This should be -1, so you would have to round this up to get the correct answer. You would have to round this up to the nearest tenth, and it's only in certain cases. This should be -1, but the computer, for some reason, doesn't handle it very well. Now, if I clear the memory, and clear the screen, and I say x equals, no, that won't work. If I say x equals well, I can't do it, to tell you the truth, but if it encounters something like 2x equals -2, and it does the division here. If you divide 2x by 2 and you divide the right side by 2, you get x equals -1. But when the computer does that division, for some reason it loses a small portion of the answer, and I don't know why. So that's the third problem with this, but overall it works pretty good. And you know, it gives you the right answer most of the time. I mean, for a 1982 color basic, I think that's pretty good. So that's it for this video. I hope you found it interesting. And just for the heck of it, I'll run it one more time and I'll put in a few random numbers that I think might work. Like, we'll make A 3, we'll make B 10, and we'll make C 5, and it instantly gives us our answers for x1 and x2. I have no way of checking these. If you test it against something you know the correct answer to, then you know whether they're correct or not, and it just needs some tweaking. I don't have enough time to tweak it right now, but I just wanted to do a demonstration that it could be done. And really all it takes is this area right here. You could do this without making a program. You could just do this as a function of BASIC. It works that way too, but I made a program out of it to make it more functional. And so that's the end of this video. I'm going to see what else I can come up with. If anybody has any ideas, let me know. And that's it for now. Bye.